Hi, my name is Zhenqi Deng. I am a graduate student of Sun Yat-sen University. Here I will present our work in ICCV 2023, named as GrowCLIP, Data-Aware Automatic Model Growing for Large-Scale Contrastive Language Image Pre-Training. Recently, large-scale cross-modal pre-training has shown impressive performance. And training these models requires a large amount of image-text pairs collected from the internet. However, it is impractical to regard cross-modal pre-training as disposable, one without considering the continuously growing nature of pre-training data or domain in real-world applications. One tough problem in the online learning scenario is that the model capacity should be related to the size of training data. To verify the relationship between model capability and data size, we split CC12M dataset and test the performance of VIT-B16 with different scales. As shown in the table, the relative performance ranking is dependent on the size of the training data. Given a smaller dataset, the performance of 0.5 VIT-B16 is comparable with VIT-B16. In the contrast, when data is sufficient, the performance of VIT-B16 is better than the smaller model. Thus, the unchanged model is not practical for this real-time learning setting, and it's still an open issue on how to modify and train our model with the growing data. Besides, how to efficiently make use of knowledge of previous model when new data is coming remains an open problem. One direct solution is to fine-tune the model with the updated training dataset. However, training with previous pre-trained parameters of the same model will deteriorate the performance due to the parameter inheriting issue. As shown in figure, the CLIP training with pre-training have worse performance than the one training from scratch. To address the above issues, we propose our method, which performs a model growth process considering the gradually increased pre-training data. Especially, when training data grows dynamically, we adopt different cross-modal network architectures via the customized neural architecture search to make the network pre-training more efficient. Different from traditional NAS approaches, we introduce a cross-modal customized NAS by defining a dynamic search space named growth space, which is enlarged when more data comes, and proposing a shared encoder search space to enhance the degree of cross-modal fusion. In our growth space, we explore the depth and width of transformer and the depth of convolutional layers. To utilize the architecture at the previous step more efficiently, the parameters of the new architecture are also inherited from the old one with momentum to maintain the previous knowledge and address the issue of local minimum dilemma. The growth pipeline at growth step T includes 3 sequential phases. At phase 1, we use the PIM method to initialize the supernet and slightly fine-tune the supernet to mitigate the performance gap among subnets. At phase 2, first, we fully optimize all the subnet in the supernet as one-shot NAS methods to find the optimal architecture. Second, after training the supernet, we search for the optimal subnet in the growth space, considering the performance and model size. At phase 3, to alleviate the influence of supernet training on the grown model, we also use PIM to initialize the parameter of selected model, and we keep training the selected model to obtain its final optimal parameters. The CC12M is randomly divided into 4 subsets. We select one subset as the training set for the first growth step and adds one subset to the training set at each subsequent growth step such that there are total 4 growth steps in our experiments. Our model outperforms the baseline methods in terms of average top 1 accuracy over 9 datasets on zero-shot classification at the last 3 growth steps, where the parameter grows from 30.0 m to 188.4 m. We evaluate the model of each growth step on 2 retrieval benchmark datasets, Flickr 30K and MSCOCO. Our model gets better as model grows and data grows. At the last 2 growth steps, it can be observed that our method has great performance on all metrics. Thanks for your listening.